This is Algebra 1, Term 3, Lesson 11. We're going to begin with a 3-act task, fast clapper, then we'll do a Desmos classroom activity, and we'll finish it out with a GeoGebra exploration of average rate of change. So let's go to our 3-act task. For Act 1, the students will be shown a video. Your link to this video will be in your show notes and in your teacher guide, and you will ask them, what do you notice? What do you wonder? So the video will show a boy clapping very quickly. So let's look at that video now. This is the 3-act task. Will he beat the record? This was shared by Nathan Kraft, and it is on Tap Into Teen Minds website. So here's a picture of the guy, and it shows the current world record. And our goal here is to figure out if this guy's going to meet or beat that record. So I'm going to go ahead and play the video.
1, 2, 3, 4.
So now the students would begin their work with their team to answer the question, is he going to meet or beat this current record of 721 claps in 1 minute? Some of the things they may notice is there is a timer. He claps fast. You only saw 4.5 seconds. And they may wonder, why is he clapping? Are those legal claps for the world record? And so forth. So encourage dialogue in your teams. But they can, as a team, come up with a strategy for figuring out if they think he will meet or beat the world record. The students will work with their team, and then they will record their work on slide 3. The next activity will be a Desmos activity, growth, decay, and rates of change. So this first screen will be a review of exponential growth. The students will be asked to type in an initial value and a common ratio. It will give them a smiley face if they get both of these values correct. Once they have those correct, it'll move to part 2 and ask them to write an equation. They can just use X and Y for these equations, by the way, and it will tell them then to use their equation in part 3 to answer a question. If they get that correct, it will give them confirmation by saying good work at the end. They will need to use this calculator, so be sure to tell them to use it, because on step 3 they ask them to round off their answer to a certain number, so they cannot just type the expression in the blank like you normally do with Desmos. You actually need to calculate it and then put the number in the blank. So they will need the calculator to do these first few items. Here's one for bacteria. Here's one for a basketball tournament with 64 teams. Here's one for the population of a city that is growing. And here is a quick recap. So on this one, they'll just type their initial value, then they'll type their multiplier. They don't type anything here. It automatically says growth or decay when they put in their multiplier. And then the percent change. I'll give you a little hint. If they have a negative percent change, they have to put the negative in front of the percent, or it's not going to say it's correct. If it is correct, they'll get a check mark on the little box. Each box gives a check mark when they put the correct answer in it, so it is self-checking. Let's move on to the next one. Now we're going on to rate of change. So we're looking at 2 linear functions that are discrete. And so the question is, which business is increasing profits at a faster rate? So students confuse the actual profit with rate on this problem. And so it's good to slow down here and talk about that. So just because a graph is higher on the graph does not mean its rate is faster. The rate has to do with the steepness of the graph, or the rate of change, the slope of the graph. So that's what this screen is for students to review that concept. And then on this one, they're doing a rate of change, and I'm asking them to draw in a slope triangle and label it. So when they label their triangle, it should have both numbers and it should have the units. And the units are on the graph for them to read on the axis. There are some teacher moves and sample responses here, so please read those if you need them. And here's where we first are introduced to average rate of change. Well, not every graph is going to be a straight line from start to finish. Sometimes we have multiple straight lines like this one, and it bends or curves. So what we will do in that case to find a rate of change between any 2 points is find the slope of a line segment connecting those 2 points. And so on this one, they will draw a line connecting the points from 6 to 10, and they can use the tool here. They can actually pick a different color if they want. I'm going to use the line tool. And then we're going to go from 6, which would be here, to 10, which is here. And this would be the average rate of change. We go from this point to this point. So how far up did it go and how far over did it go? They can also draw slope triangles here as well. They will see that in a later activity today, actually. They're going to do the same thing here. They'll connect A to B. So they can use blue or they can pick another color. They're going to figure out which of these is the change in Y over the change in X, which is in this case the change in voltage over the change in time. And on this one, we're using change in voltage over change in time, and they're going from B to C. And this one's going from C to D. What is the time interval? So in this case, just like we had the time interval from 3 to 5.5, what is the time interval if we go from C to D? And so they'll need to kind of read those off the graph and then find the average rate of change from C to D, and be sure to include units in the answer. So once again, they're simply finding the slope of a line segment that connects the endpoints over that interval. Here they're going to compare all the different ones. So they had a rate from A to B, another rate from B to C, and another rate from C to D. So if you look at all of those, you could actually maybe write those up on a board in front of the class and let them see all three at the same time. And then they will choose whether the rate of change is constant, is the rate of change increasing, or is the rate of change decreasing. Now here's where we get into that same concept. This graph is increasing everywhere, but is the rate of change on the graph increasing everywhere? So that's a very good, it's one of those things they really have to think about when they do it. All right, this time we're doing an average rate of change from 0 to 3. There's nothing on the graph, so they will need to look for these values of x, and they will need to connect the points with a line segment and then find the slope of that line segment. And then they will do it again from 7 to 8. So they will take a point at the 7, a point at the 8 on the graph. They will connect the 2 points and find the slope. The average rate of change, they still need to put the units on each one of these average rates of change. And that concludes our Desmos activity. Now, it doesn't really take that long, except for it is new. And I guess it depends on how strong the students are at their exponential growth and decay. So that could take some time. I intended that part to be mostly independent work, but if your students are struggling, you may slow down and talk a bit about growth rate versus percent growth. Let the kids talk about it themselves in their teams. Have a student come up and maybe demonstrate. Our next activity is to do an exploration in GeoGebra. So the GeoGebra task is to go to GeoGebra, and then they will move some points around to create an average rate of change. This time they're going to create the average rate of change of 1/2. So click on GeoGebra to open, and then scroll down, and here it is. Now, it just so happens the average rate of change is already 1/2, so they won't have to do anything on this first one, and they could just use the same one. But if they want to, they can move these around. So I can move this. Notice I'm moving the black point, and that average rate of change has not budged. And that's because those 2 points, even if I change the curve on the graph, there's still points on the curve. So encourage them to do that. Encourage them to move this stuff around and see what's happening. And then they will take a picture of it. Now, the next thing it says to do is create an average rate of change of -1/2. Well, they're going to have to move something to make that happen, because if they don't move anything but the black, it's not going to change. Now, if they move this along the curve and they move this along the curve, you see, I can look at the slope, there's one, and get an average rate of change of 1/2. There are basically an infinite number of correct ways to do this, because you can move this up, you can move this down, and it sometimes gets crazy. Like, let's say I do, we just reverse this. Let's say I do something like this and the stuff gets off the screen, and that does happen. I tell the students be sure to click on the reset button in the top right and it'll go back to the way that it was. They can also zoom out and zoom in. They can use their trackpad, but they can use a mouse wheel if they have a mouse to move out and move in if they need to zoom out and in. But the rate of change is right here. They may notice it says rise over run and delta over delta x. I don't use the terms rise over run, but most of the kids that have used it in a prior class. So they will, if they haven't made the connection yet, the delta y is the rise and the delta x is the run, and it's showing that on their slope triangle. Anyway, that's what they're doing for 4 slides. It gets a lot more challenging when they have to do the 2 and the -2. And if you want to, you could add a 5th slide and say create your own. Choose some rate of change different from the previous 4 and insert a screenshot. So they could do that, maybe even talk about it. If they wanted to make a video talking about it and insert that into their portfolio, that would be something uniquely theirs. I did not include an extra slide for that, but you could add an extra slide. Just duplicate this slide and change the text and make it your own. So that concludes our average rate of change lesson. Next time we'll put it all together with some problem solving. Y'all have a great day.